Howdy. Let's talk a little bit about what's going on in Greece. Here we have Santorini, the island, and since a while I have been very intrigued with the Minoan eruption. The Minoan eruption was a catastrophic volcanic eruption that devastated the Aegean islands of Thera, also called Santorini, around 1600 BCE, before the Common Era. In other words, somewhat 3,500 years ago. For those who are aware and know about the works of Immanuel Velikovsky, Dave Talbot, Walt Thornhill, and other people, this time there might be some bell ringing, because around this time there has been many other things going on Earth, and when the first time I heard this some time ago, when they were talking about the Minoan eruption, and it was happening about 1600 before the Common Era, I was very intrigued, because it's approximately the same time age, the late Bronze Age, 1200 BC, where many things happened. And if you scroll down here on Wikipedia, and I intentionally use Wikipedia because, yeah, it's available for everyone. You just have to take many of the things here with a grain of salt, or you just have to know what you're looking at or what you're searching for. So, Shamash, Saturn. But there was some thing here further down somewhere here. I won't dive in some of the details or many of the details. The Bronze Age collapse theories have described aspects of the ends of the Bronze Age in this region. Yeah, check it out. It's this region where what we are talking about. At the end of the Bronze Age in the Aegean region, the Mycenaean administration of the regional trade empire followed the decline of Minoan primacy. Several Minoan client states lost much of their population to famine and pestilence. Yeah, I could make a very long video, but I won't. This is a rather short video. I will put the links below. Actually, it's not this page. I think we have to go back to this. I'm sorry. I didn't really prepare this video at all. I've been thinking about making a video, now I just make it. So, because I stumbled across something, at least to me, very interesting. Yes, very interesting. Sulfate spike estimated 2 to 8 trillion grams of sulfur. Yeah, that's right, a trillion grams sulfur. Oh, they could maybe put tons in this. Sulfide spike estimated 10 trillion grams of sulfur. Large sulfate spike. Sulfate spike estimated 6 trillion grams of sulfur. Sulfate spike. Yes, I know many people associate the sulfur to volcanic eruptions, and yeah, it's still nowadays. If something big is happening or happened back in the days, very often it is either or it was a volcanic eruption or it was an asteroid that was smashing into Earth. These are the two tools that modern mainstream science has to offer in order to explain most of the things. And if those two things aren't sufficient enough, it was gravity or your fault. But that's another theme for maybe some other videos. But I wanted to point out this. They are talking about sulfur many, many times here and that. And for those who are aware of Velikovsky's work, Dave Talbot's work about Venus, the great comet Venus. Here we can see some ancient depiction, maybe that's from Southern America or something, but that's the comet Venus and it had a very big tail. Universe today, that's Venus. You can see it's red, white, yellow. And for those who have seen some of my or have seen my Finnish copper playlist, you learn that sulfur is recognizable with three colors. It's either white, red, or yellow. And if it burns, it burns with a blue flame. Venus has clouds of concentrated sulfuric acid, but life could still survive. That's not the point. And if we go down here, the surface of Venus captured by a Soviet Venera probe, Russian Academy of Sciences. Yes, yellow. So there seems to be a lot of sulfur on Venus. And as I've been theorizing in my Finnish copper playlist, that much of the sulfur, not the sulfur that is coming out of volcanoes, sulfur occurrences where we don't really have volcanoes, and the copper on Earth might have its origin from Venus, from back in the days when Venus was close to Earth and people were afraid of that because Venus had interactions with Earth. Stuff went down, thunderbolts of the gods. And also, for those who don't know Andrew Hall, I really recommend you to watch at least this video from Andrew Hall. We are looking at this Thunderbolts Project website. In part 1 of this presentation, Thunderbolts contributor Andrew Hall explored the role of electrical discharges in earthly volcanism. Hall compared the physical characteristics of volcanic fields called the Mars of Pinaceti with strikingly similar features on the Moon and found in both evidence for high energy electric discharges. In this episode, Hall considers the evidence in earthly volcanism for the electrical circuitry between the Earth and the Sun. Yeah, but I think many volcanoes on Earth were originally created by huge discharge events. A very big lightning strike struck the Earth and therefore created basically a hole in the mantle, and we still have a volcano at that place. Not all of the volcanoes, but some of them. And that's Also, something that I found really, really interesting when I heard about the Minoan eruption happening about 3,500 years ago, when all the stuff went down with Venus. And I found that very interesting. And now we have to go to Google Earth quickly. And we go here into Santorini. When I looked at Santorini recently, I somehow thought that, yeah, this might be some kind of an crater of electromagnetic origin. And in order for you to show something what I found interesting, that in a way could give my claim of this volcano being originally created by electromagnetic discharge events is this picture here. Beautiful rock formations in Santorini. We have I figured probably out a way in order to tune in into Google Earth pictures. We have those columns. Of course, they are layered. This is not something too special. But the thing is, they are more or less vertical. They are not straight vertical, but more or less vertical. And I just found only one picture of these from Santorini, which is also interesting. Why aren't there more pictures of this feature? I don't know exactly where it is, because if you look at some other pictures, yeah, that's volcanic. Maybe the yellow stuff is sulfur, maybe it's iron, I don't know. But there are not really more pictures of them. Yeah, here we can also see vertical structures. There might be also indication of something. And here we have those layers, horizontal layers, lateral layering. Maybe some shockwave features. But if you dive into Andrew Hall's work, he is much better in explaining these. Yes. And there are some hot springs here somewhere. Like them. Yeah, there's different kinds, different water here. And also here, these rocks are very intriguing to me. Because this shore looks totally different from this shore. There is a difference between those two, but it's very bad quality. So we won't dive into that. But anyway, here we have Santorini, and here this is Colombo, and the earthquake swarm is somewhere here. So it's not really Colombo or Santorini. It's much more in this region here. Maybe this is Anudros. Maybe that's a place we ever should take a look at closer once. Maybe there's some ancient stuff. The color is very odd. Doesn't really, you cannot really see anything. Let's see, we have some pictures from here. '17 pictures. Yeah, that looks very interesting here. We have these kind of inclusions. We have somehow vertical structures. Maybe some shockwave patterns here. Yeah, this looks very interesting. Yeah, this looks very interesting. So it was probably the wind came from the right side of the picture and stuff started to pile up here. There's like different materials here, and then we have different materials here. Yeah, to me, this doesn't really look like average volcanism. Yeah, but anyway, you can go to check the pictures for yourself. I want to talk still about a few other things. For example, the basalt columns, what we just looked at in the first picture from Santorini. We have been walking on the bubbly rocks of an old lava flow, or for what seems like miles. Though the rocks under your feet change in color and shape, many look similar, small, warm, and full of tiny pockets. Yeah, that's really strange. In this case, the lava starts to crack into regular shapes. Those shapes are forming because of how the lava cools. It starts at different spots called centers. If those centers are evenly spaced, the forces that pull inward toward the centers end up creating different chunks of cooling lava that are hexagonal. Really? So I've been wondering about these for many years. Here you can see what I tried to explain earlier. With different layers of material. Yeah, that looks that's a very interesting place. Different layers of material, and the thing is, they are most often vertical. We can find basalt, uh, these kind of columns all over the place. And I just thought I would like to find out how. Yeah, I was just wondering, is there any possibility if we could see this process anywhere going on, As we just learned, it's just because of the lava cools in a certain way. And there's like many volcanoes erupting all the time on Earth. Hawaii, Iceland. You could somehow expect that those basalt columns would just form like all the time. And we could go and take a look at them. Columbia River basalt group stretches from Oregon to Idaho. The Columbia River basalt group is the youngest, smallest, and one of the best preserved continental flat basalt province on Earth, covering over 210,000 square kilometers of mainly eastern Oregon and Washington, western Idaho, and part of northern Nevada. So it's the youngest. All right. The thick layered lava flows of the CRBG erupted as flat basalts, which originate as some of the most highly effusive eruptions in the world. Yeah, it's again, they are just talking about volcanoes. The CRBG sequence, a classic example of flat basalt activity that erupted more than 350 lava flows from around 16.7 to 5.5 million years ago. Yeah, that's the youngest. The youngest is at least 5.5 million years ago. For those who have been watching some of my videos, you probably have noticed that, or remember how I somehow figured that they are trying to explain their lack of understanding of things with obscuring geological processes and occurrences and stuff like that with age. Yeah. So you have to ask yourself, how is it possible that we had in the last 5.5 million years, we had many volcanic eruptions on Earth, all right? Like, maybe a few weeks ago, we had the last one. Maybe not even that long ago. Hawaii. But yet, still, those basalt columns, hexagonal in shape, the youngest are 5.5 million years old. Does this make any sense to you? You have to ask yourself, how is it possible that back in the days it was possible to create these basalt columns, and you can find them all over the place. They are all over the planet, in many places where we don't really even have any volcanoes or actual volcanoes, but yet we have still basalt columns. So, one thing is, you have to understand that Earth's electric field is vertical. This is just some random paper I found. Antarctica, GOV, Australia. This document seeks to give practical meaning to the theory describing the electric field between two parallel plates by showing its application in our understanding of Earth's vertical electrical field. It is hoped that the fact that the example is set in Antarctica will add to the interest generated by the example. That's one of the weirdest sentences I've been reading for a while. But anyway, the illustration is aimed at students of upper level high school physics. They will need to have a qualitative knowledge of the physics associated with a pair of charged plates and the electric field that is formed between them. The relationship between resistance and current, Ohm's law, is required to understand the reason for citing the experiment on the high Antarctic plateau. Let me just check something. Yeah, we're still recording. Anyway, now I want to show you a very complicated picture. Ionosphere, Earth's surface. The Earth's electric field is vertical, as you can see here. And as I have been explaining in the beginning, we had the comet Venus some 3,500 years ago, which quite likely enhanced Earth's electric fields very, very strongly. And I think, let's go here, back to Santorini. And I think this process of enhanced electromagnetic fields on Earth created not only these columns of basalt that are rather vertical, but also all the others. And we also need to understand that my theory about the copper and the sulfur, if we zoom out just a little bit here from Santorini, we will find Cyprus. And the ancient name for Cyprus is Cuprum. The Romans called it Cuprum, and Cuprum is the ancient word for copper. And not far from here, we have somewhere here, I don't know where exactly it is, Sodom and Gomorrah, where Ryan Watt actually found sulfur balls. Probably the ones that are talked or described in the Bible. So, Santorini isn't actually too far from the places where back in the days happened many historical events. So, the electrical field is vertical. No, I don't find the nice picture anymore. Maybe it was here. Yeah. These are vertical too. So to me, this is rather good evidence that not only were they possibly created around the times when Venus made its approaches to Earth, or maybe later Mars made its approaches, or even some very strong solar activity when we had a very strong magnetic field and electrical currents that made these columns of basalt because they are vertical. And if this doesn't sound strange enough, let me show you something. This is from one of my videos. This is from Popocatépetl. And I found this when I made the actual video. Let's go just a little bit back and have a quick look. I want to make, we don't listen to actually what I'm saying. It's just now you can see the video. You basically can see the moment I discovered or noticed this very strange feature. And it's actually maybe here visible already in the background. These, I'm not too sure. Kind of structure. And these are screenshots from a video, and they are enhanced. Now here you can see it already. What's that? This looks like a Berkeley current. And that's Popocatépetl in Mexico. And this is somehow going through the cloud upwards. And if you now take a look at this, and Berkeley currents are like energy currents. Earth is connected to the sun via Berkeley current that goes in the poles and goes out of the poles. It's where the polar cusp is. And the Berkeley current and the plasmoid at the center of Earth are, I think, creating the magnetosphere, the ionosphere, and the atmosphere, the layers of the atmosphere of the sun. Let's see if there's any. Yeah, here it should be enhanced. Yeah. Check this out. That's amazing. That's a screenshot from, I think it was some news about Popocatépetl erupting. And that's amazing. This goes into the clouds. You can see how it goes in the clouds. So this could be a very nice indicator about the electrical nature of modern day volcanism until this very day. And if you don't know about this, but I have a whole playlist about this. I didn't make any volcanic plasma phenomena. You can see there's a whole lot of stuff about plasma phenomena on different kinds of volcanoes. Let's have a quick look at these. Just in order for you to know, these are screenshots and enhanced for you to see. That's the plasma, that's the actual eruption. Yeah. So that's the actual eruption. You can see lava bombs here flying around. And this is beside the actual eruption. That's plasma. And this is morphing, this is moving. And here we still, that's the remnant. Here we have this other shape, triangular shape. And these, I call them streamers because they are going upwards at the end of the eruption. But anyway, let me still show you, I want to show you still two things. Let's talk first still about Santorini. Hopefully you remember what I've been talking about in my last video about the aluminium, that clay and lava is basically the same thing. A distinct source and differentiation history for Kolombo, submarine volcano, and Santorini volcanic field. Because, like I try to explain all the time that I think there is a slight possibility that Santorini, the big eruption that happened in 1650 AD, probably wasn't an actual volcanic eruption. It was probably more an electromagnetic discharge event that created the island. And the volcanic activity that we still see nowadays is a remnant of the electromagnetic discharge that happened 3,500 years ago. Maybe because of the approach of Venus. Who knows? I don't know. But let me point out something. The strong geochemical signature of amphibole fractionation and the assimilation of lower crustal basement in the petrogenesis of the Kolombo magmas indicates that Kolombo and Santorini underwent different crustal differentiation histories and that their crustal magmatic systems are unrelated. Kolombo and Santorini magmatic systems are unrelated. I don't know. I haven't been hearing anyone talking about this. But here they tell you it's the abstract. It's really the beginning of the whole paper. You can check it out. I'll put a link below to that. It's free, actually. Check it out. You can just download this. Open access collection. So, Santorini and Colombo are not the same. They underwent different crustal differentiation histories. In other words, they were created differently. But let me show you still something about the petrology of these. There's titanium oxide, but I have also in one of my microwave pebbles. But since they are not willing to send me the full data set, I'm a little bit, yeah. It would be nice if they would send me that. Or maybe they know why they don't. Probably they have reasons. But andesitic lavas are characterized by higher aluminium oxide concentration, 17.7%. Hmm. But there was something more. Colombo lavas are basaltic to andesitic in composition and overlap with Santorini for magnesium and potassium contents, but the andesitic lavas are characterized by higher aluminium content. The silica content of the mafic enclave in K2 pumice sample is similar to the Colombo lavas, but is distinct in magnesium and oxide and trace element concentrations. In terms of major element composition, the K2 and 1650 AD pumices are similar but not identical. The 1650 AD pumices are marginally lower in silica and aluminium oxide, but Na is that salt and potassium contents are the main difference. K2 pumices have lower alkali concentrations, even though K2 classes are characterized by higher K2 contents. Yeah, it would be interesting if they would have found anywhere shocked quartz there. But let me show you still yet another thing about volcanoes, because I've been talking about geothermal activity and about water being probably, or logically thinking, or logically thought, laterally thought. Since Earth is the water planet, we might too expect that the most eruptive material, or the material that is erupting the most on Earth, is water. And even though that water that is not hot, in a sense of being hot, like hot springs, like the Yellowstone ones, uh, that we have to consider all those water sources on Earth basically as volcanic in nature, and like even though the water would be cold erupting somewhere, it is still volcanic in nature. Let me show you something I found recently, and actually I thought that I will talk about these in my last video. I wanted to show you this Santorini and Colombo thing, that they are not the same. They weren't made in the same manner. And I also wanted to show you still. I wanted to show you still this. Now let me check. Yeah, I think it's recording. Yes. Anyway, sanctuary for vulnerable Arctic species at the Borealis mud volcano. Yes. Abstract. That's also paper for free. Download PDF. Borealis is a recently discovered submerged mud volcano in the polar North Atlantic. Yes, differing from the numerous methane seepages previously identified in the region. Here we show in situ observations from a remotely operated vehicle capturing the release of warm 11.5 degrees water. Yes. If I would fill a bathtub for one of those many, many scientists who are involved in this, or were involved in the making of that paper, and it's rather new, 27th January 2025. So if I would fill a bathtub and would offer to this other Stefan Bunz, he might be even a Swiss person, I don't know, maybe, I would fill a bathtub and would tell him that, yeah, Stefan, check it out. I fill a bathtub for you with warm water. Go there and enjoy. The water is 11.5 degrees. Probably would disagree with me. No, it's not cold. I won't go there. I cannot relax in 11.5 Celsius warm water. But here they're still talking about warm, right? Maybe they didn't want to use, yeah, maybe they didn't want to use the word warm, but yet still they're talking about warm water. Here are some very nice pictures. 20 centimeters, okay? It's not that big. Here we have Norway. Here we have giant craters. And for those who know, we cannot see anything on Google Earth, and I found this very cool map application some time ago, maybe a year or 2 years ago. Made some videos using the app, and nowadays it's not usable anymore. They shut it down. I doubt it's my fault. I don't know, but it's still interesting. Here we have the Borealis mud volcano, and here we have some other mud volcanoes. MV is mud volcano. Methane seepages, gas flares in the water, flares. Octocorals. Yeah, I've been theorizing that basically I think all the coral reefs and raised bogs, they're talking about peat. But I have been thinking about even making a video about these, bringing forth my idea, theory, or however you want to call it, that coral reefs are volcanic in nature. Yeah, carbonate crust. Here we have the crust, and here we have the corals. Octocorals. Yeah, and the volcano. Hmm. Yeah, there's methane coming out and stuff. So where we have methane, we might find even oil. Hmm. But anyway, I think I leave it here. Borealis mud volcano, and it's not that deep here. But if you go to Google Earth, somewhere here. But of course, since it's about 7 meters in diameter, we don't exactly know. And maybe I have a place mark. I put a place mark here. No, I marked it here on the map, but you can't see it. You cannot really see anything. But anyway, so much about volcanic activity, genesis of volcanoes, the genesis of history, and what we are told, or what we were told in school, and what turned out later to be much more likely the case. Yeah, I think I'll leave it here. Hopefully you get something out of that. And yeah, maybe I will make some other videos in some time talking about some other stuff, which is all the same stuff. Let me show you still another quick mud volcano from the Alps. This looks very muddy to me, muddy waters, and it's basically in the middle of a glacier, which is in the middle of the Alps. No, it's more at the edge. But anyway, take care, Earthlings. See you. Bye.